deriving the equations of motion. So kinematic equations are nothing but equations of motion, are also called as law of constant acceleration. So what is a plus b and a minus b? In mathematics, a plus b into a minus b is a square minus b square. What is BC here? I want to know what is BC. If you want to know what is BC, BD minus CD gives you BC. Hello everyone, I am Nishma Nanjama, Faculty of Physics in Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. Welcome back to session 4 on chapter 3, Motion in a Straight Line. So in session 3, we studied the position time graph, which gives us the slope of position time graph, gives us the velocity of a body. And the slope of velocity time graph gives us the acceleration of the body. And slope under the area of graph gives us displacement. So I hope you remember the note that I had given in the previous session. So after xt and vt graph, after the graphical representation of motion, next we shall move on to kinematic equations. Kinematic equation for uniformly accelerated motion from velocity time graph. So kinematic equation by graphical method. So we are using velocity time graph. What does velocity time graph give us? Acceleration. Slope of the velocity time graph give us acceleration of the body. So using this VT graph, we are deriving the equations of motion. So kinematic equations are nothing but equations of motion, are also called as law of constant acceleration. So we have 3 equations of motion. Let us quickly derive these 3 equations of motion. Before we derive the 3 equations, we need to understand what do you mean by uniformly accelerated motion. What is accelerated motion? What do you mean uniformly accelerated motion? Suppose you are driving a vehicle on the road. The velocity of vehicle is never the same. So the velocity of vehicle is increasing or decreasing. If you get a traffic signal, you will stop. So again, when the person is crossing the road, you will stop. Somewhere your velocity is not the same throughout your journey. It will increase, it will decrease. So as you move, the velocity of the vehicle increase or decrease. So this is called accelerated motion. So decrease, you raise the speed. It is accelerated motion. Then what is uniform motion? If a body is said or object is said to possess uniform motion, if it is acted under constant velocity. If it has constant velocity, that is, it undergoes equal displacement in equal interval of time. What is velocity? Displacement by time. If it undergoes equal displacement in equal interval of time, that gives you uniform velocity. If you have constant velocity, then the object is said to have uniform motion. The object is under uniform motion. If there is change in the direction or magnitude of velocity, because velocity is vector quantity, it depends on both magnitude and direction. So if there is change in direction or in magnitude of velocity, then the body is not in uniform motion. If it has constant velocity, we say body possess uniform, body is under uniform motion, moving with uniform motion. So this is what we call uniformly accelerated motion. So we'll quickly go through the kinematic equations or equations of motions. Terms to know. So you should know few terms before you start deriving the derivations. In figure, you can see the figure to the left here. So you have a 2 axes, time and velocity. Time along x-axis and velocity v along y-axis. So we are using velocity time graph and deriving the expressions for equation of motion, that is kinematic equation. So you have your VT graph here. You have your VT graph. So in this figure, look at in this figure, the object is initially at origin. It is at origin. From initial position, it starts to move. It starts to move along the y-axis. It starts to move along the y-axis with the initial velocity u. The object is at rest at O. From point O, the body starts to move along the y-axis with initial velocity u up to point A. From A, the body is displaced to point B. From the point A, the body is displaced. The body is displaced to point B. The body is displaced to point B. This straight line gives you uniform acceleration. Uniform acceleration. It gives uniform acceleration. So, from point B, I drop a perpendicular line to D. This D on the x-axis. So, the object was at origin. It started to move with the initial velocity u along the y-axis up to point A. From point A, the body was displaced. It was displaced. This straight line displaced to point B. From point B, I drop a perpendicular. This is perpendicular. So, perpendicular line to x-axis, and I'll name it as D. So, as time increased, the body was displaced from, as time is increasing, as t increases, you can see the object is displaced from position A to B. So, this straight line is nothing but uniform acceleration. It is giving you uniform positive acceleration, and I have drawn a perpendicular to x-axis, and from A I have dropped a perpendicular from C to A. I have dropped a perpendicular from B to D, and from C I have dropped a perpendicular to A, which is on the y-axis. Your initial velocity from the origin, when the object started to move from origin, your initial velocity was u, and now your final velocity after reaching point B, your final velocity BD, the perpendicular line which I have dropped from B to D, your final velocity is V. Initially, you started with velocity u. After reaching point B, your velocity is v. So, this is the explanation regarding the diagram. So, what are the terms that you have to know in this diagram is given here. From the figure, you can say OA. What is OA? OA is u. OA is given with u because the object is moving with initial velocity till point A. So, here OA is given with u. And you can see displaced, the body is displaced from A to B, and from B to D, the final velocity is V, because y-axis you have given velocity. So, this line is parallel to this line. So, y-axis has velocity. So, your BD is V. Now, what is BC here? I want to know what is BC. If you want to know what is BC, BD minus CD gives you BC. So, what is your BD? BD is nothing but V. It is parallel to y-axis. So, it is V. You know BD is V. Now, what is DC? This DC is parallel to OA. OA is U. Then CD is what? It is also U. This velocity axis is parallel to this axis. So, this is V. This is also given by V. So, your BD is V. Your CD is parallel to AO. When this is parallel, when OA is U, CD or DC is also U. So, you have BC. If you want the whole line, this line BC, this whole line is BD. So, BD minus CD gives you BC. So, what is BD? You got to know it is U minus DC is U, and you will get that as BC. Your BC is V minus U. So, what is OD? OD now. OD, it is T, time along x-axis. OD is parallel to AC. So, AC is also T. OD is along x-axis. Your x-axis is given by time. So, OD is parallel to AC. So, AC is also equal to T. So, OA is U, BD is V. BC is equal to BD minus DC is U minus V, and you have OD is equal to AC is equal to T. So, the displacement S of the body in a time interval T is equal to area A OABD under the line AB. So in the previous session, I have explained you area under the straight line. So area under the straight line AB, that is OABD. OABD gives you displacement. In the previous session, in the note, we read that area under the curve gives you displacement. So the straight line, area under the straight line gives you displacement, that is S. So that is what is the meaning of this line. From figure, we know area AOBD, this is nothing but a trapezium. It has parallel sides. So this OABD, this is a trapezium. So trapezium is nothing but equal to area of rectangle plus area of triangle. So which is the rectangle here? This is your rectangle. Area of rectangle plus area of triangle gives you trapezium AOBD. So these are the terms, things that you have to know to derive the equations of motion. So let us begin with the first equation. You have V is equal to U plus AT. So I said you have two axes X and Y. So you have velocity along the Y axis and time along the X axis. So initially this is your origin. So body starts to move with the initial velocity up to point A. From point A, the body is displaced to point B. This is displaced. So displaced means it is a straight line. It is uniform positive acceleration. From B, I will drop down a perpendicular line to name it as D, perpendicular line to time axis. And I will drop a perpendicular line to Y axis. I'll name it as C. So this is a time axis, I is a velocity axis, and ABC is your triangle, OACD is your rectangle. So rectangle plus triangle gives you, this is the trapezium. So you know it is moving with initial velocity. So OA is U. So this is, you know, BD. Overall it is V because it is parallel to Y axis. Y axis is given as velocity. So your BD is equal to V. So your BC is equal to, we have seen in the previous slide, it is V minus U is your BC. You see, it is your BC. So OD, it is T. So your AC is also equal to T because they are parallel. So with this diagram, let us derive this expression. You have V is equal to UT plus AT. What is V here? Velocity of the object. U is the initial velocity. V is the final velocity. A is the acceleration of the object. T is the time. Now, how will you derive this? So, acceleration of body is equal to what? Change in velocity by time. So change in velocity, what is your change in velocity here? Initially it was U and final velocity is V. So final velocity minus initial velocity will give you change in velocity. It is change in velocity by time. So change in velocity is final minus initial by time. So this will give you acceleration. This will give you V minus U by T is acceleration. So you have acceleration of the body A is equal to V minus U by T. Take the T to the LHS. So it will be, when from denominator, from division it goes to LHS, it will be multiplied. So AT is equal to V minus U. So AT is equal to V minus U. So on shifting the terms to LHS, you get V is equal to U plus AT. So we get back into the initial equation, that is 1. So from equation 1, we calculated acceleration of the body. Acceleration is change in velocity by time. So change in velocity is nothing but final velocity minus initial velocity. Final velocity is v and initial velocity was u, divided by time is acceleration. On shifting t to LHS, it is AT is equal to v minus u. On shifting the terms to LHS and shuffling the terms with LHS and RHS, you get v is equal to ut plus AT. This is the first equation of motion. Next, you have second equation. So, you're finding displacement. S is displacement of the object. Ut is, u is what? U is your initial velocity. T is time plus half A is your acceleration, time square. So, this can also be asked as, instead of v, it can be asked as v naught. If few textbook, it is given initial velocity is given as v naught. In few textbook, it is given as u. And instead of x, you can get the question as x is equal to v naught t plus half a t square. So, both are one and the same. So, don't get confused. So, instead of x, you can get s also. Instead of v naught, you can get u. It is all how you represent initial velocity and displacement. So, s is equal to ut plus half a t square. So, we have two axes, that is time and velocity. The object was initially at O. It is moving with uniform velocity up to point A. From point A, it is displaced to point B. So, this is S. You need to calculate S displacement in this equation. From here, I'll drop down a perpendicular to x-axis, that is D. So, this is also equal to T, and I'll drop down a perpendicular to A. I'll name it as C. This is also your T, and this is V minus U, and this entire term is V. So, this is velocity. So, from this, I should calculate S is equal to ut plus half at square. So, the area under the straight line gives you displacement. Area under straight line gives you displacement. Now, how will you calculate this? What is area of OABD? Trapezium is equal to area of rectangle OADC plus area of triangle ABC. So, what is area of rectangle? It is length into breadth plus what is area of triangle? Half into breadth into height. So, this is your triangle OADC. So, what is length and what is breadth? So, your length is OA. Your length is OA into breadth is OD plus half. What is breadth into height? Breadth is your, this is your triangle. This is your triangle. So, what is breadth here? AC into what is your height here? Into BC. So, what is OA? OA is U into what is OD? It is T plus half. What is AC here? What is AC? OD and AC is nothing but T. So, it is T into what is your BC? What is BC? We know it is U minus V minus U. So, what is V minus U? From the first equation of motion, we know V minus U is nothing but what is U minus V there? It was AT. So, it was AT. In our first equation, we know V minus U is AT. So, substitute that here. Substituting that, you get UT plus half T into AT. I have substituted AT. So, you will get UT plus half AT square. So, area is equal to, that is area of OABD is nothing but S. So, area under straight line is nothing but displacement S. So, S is equal to UT plus half AT square. So, area under the trapezium is given by area of rectangle plus area of triangle. You have rectangle, you have triangle. So, under that the formula is length into breadth plus half breadth into height. You get UT plus half T, half t into u minus this. Take this as equation 1, which is important to solve the next equation. On simplification, the value of v minus u, we have at. So at, substituting that here, we get the final equation, that is the second equation of motion. Similarly, you have the third equation. Final velocity square is equal to initial velocity square plus 2 times acceleration into s is displacement. So, the same diagram, you have x-axis, you have y-axis, time along x-axis and velocity along y-axis. From 0, the object is moving to point A. From point A, it is displaced to point B. From point B, I will draw a perpendicular line to x-axis and I will name it as D, and 0 to D it is T. So now I will draw a perpendicular from C to A. It is also equal to T. Initial velocity of the object is U and final velocity, this line is parallel to BD. So BD is nothing but V. So BC is BD minus CD, V minus U. With using the same diagram, I will derive the third equation. So, what is the area under? Area of OABD. Area under OABD. So, this is the trapezium. Trapezium area of OABD. It is trapezium is equal to area of rectangle plus area of triangle. We know what is area of rectangle? It is length into breadth plus what is area of triangle? It is half into breadth into height. Use this here. Using this, we know from the previous derivation that it is ut plus half t into v minus u. So, it is u into t plus half, breadth is given by t into v minus u. From the previous derivation, from equation 1, we know that what is the area of rectangle and area of trapezium. So, area under the straight line is nothing but displacement. So, S is equal to, you got this equation from previous derivation. So, now multiply the equation by 2 on LHS and RHS. So, now multiply 2 on LHS and RHS. You will get 2S is equal to 2UT plus 2 into half of T into V minus U. Multiply T inside. You will get 2UT plus half and half get cancelled. You will get Vt minus Ut. 2S is equal to 2Ut plus Vt into minus Ut. 1 UT get cancelled. So, you get 2S is equal to Ut plus Vt. So, take common U plus V. T is taken common is equal to 2S. So, 2S, bring the T to the denominator. It is in the multiplication. When you get it to the LHS, it becomes division. To 2S by T is equal to U plus V. To consider this as your equation 1 and this as your equation 2. And also we know that V minus U, you have U plus V here. V minus U is equal to AT from our first equation of motion. So, consider this as equation 3. You have equation 2 and equation 3. Multiply equation 2 and equation 3. Multiply equation 2 and equation. So, on multiplying these equation 2 and 3, next you have multiply equation 2 and 3. So, you will get 2S by T into AT is equal to U plus V and V minus U. So, what is A plus B and A minus B? In mathematics, A plus B into A minus B is A square minus B square. A square minus B square. So, T get cancelled. So, 2SA is equal to V square minus U square. v square minus u square. So you got 2a is equal to v square minus u square. So I can write it as v square is equal to, take this to LHS, you will get u square plus 2as or SA. So this is the third equation of motion. So this is the third equation of motion. So we consider the area under the straight line BD is nothing but displacement S, that is equal to trapezium. The formula is area of rectangle. This is your rectangle plus area of triangle. Area of rectangle is length into breadth. Triangle is half breadth into height. So on further simplification, multiply the equation from the previous derivation. You know what is the area of triangle? It's length into breadth. Area of triangle, breadth into height. You have multiply in both the sides. You get 2s is equal to 2ut plus half. Multiplying LHS and RHS by 2, you get this equation. On cancelling and multiplying the terms, you get this equation. Then 2s is equal to ut plus vt. So take t common, you get 2s is equal to u plus v. So bring the t to the denominator of LHS, so it will be division. So you have two equations. This equation is from the first equation of motion. V minus u is at. So multiply these two equations, you get this, and from the mathematics we know this is nothing but a square minus b square. We have v square minus u square. So that is equal to, on shuffling the terms, v square is equal to u square plus 2as. We came back to this equation. And here we know area of triangle, area of rectangle and area of triangle. It is OA into OB, half breadth AC into height BC gives you this equation, Here this equation from equation of motion, first equation of motion we know v minus u is at. Substituting that, we get this expression for equation 2. So in the next derivation, we have not shown the simplification part because we have done in equation 2. So I have directly taken this form which I have taken as equation 1. Using this equation 1 from the second equation, I have directly put that here and simplified. So that's all for today's session. In today's session, we studied the kinematic equations, that is nothing but the equations of motion, 3 equations of motion using VT graphical method. So I hope the terms in the diagram are clear, and these are the 3 equations of motion, how we derive the expression. So remember these 3 equations of motion for the next session. So I'll be coming up with more interesting sessions on motion in a straight line. So until then, take care, have a good day. Thank you.